What's up everyone? So we're going to continue configuring VXLAN, and on this video we're going to deploy VXLAN using EVPN, and I'll still using the configuration guide for Nexus 9000 series. Right now I'm still using version 9.3 something, 9.3.6. And for EVPN, you can see the requirements and some information at how to deploy this. So essentially, we're going to deploy the flood and learn mode, and on top of that, we're going to deploy BGP EVPN. So let's just get right onto it, and I'll use Notepad to speed things up. So first thing, we have to enable the IGP, the OSPF protocol we'll be using, and we use PIM as the multicast, and we're going to enable OSPF routing process. Going to set the router ID to the loopback interface. Now use loopback 0 with the address 192.1.32. Enable OSPF at the interface and IP PIM sparse mode. Now to configure the RP, we're going to use Encast gateway. This is going to be an IP shared between the spine 1 and spine 2. I'm going to add one additional interface, and that's going to be loopback 1. And the address is going to be 0112.32, and I'm going to advertise this as well and enable multicast on this interface. And the RP address will be this new loopback 1 IP for 224.0.0.4. Yes. And the IP PIMs source specific multicast, it will be 232.0.8. And I have to say that it's IP PIM, I believe, Anycast. It's 192. I'm not sure. Give me a minute. Let me start copying and pasting this, and you're going to see the next parameters. So enable these. Okay, this is done, and until here, I'm sure. And for spine 2, oh yes, it's IP PIM SSM range 2, but I believe, if I recall, this command is going to be added automatically. Yes, it is. Now loopback 1, is it? Yes. Now I have IP PIM Anycast RP, and that's going to be the IP 012, and the real IP is 192.168.1. And we're going to do the same for spine 2 loopback address. Now it is out of the way, and now the interfaces. Let me get this part configuration. Just and just get all of this. Now the interfaces, they will be 2 to 4, and I want to enable the interface. This has to be a layer 3 interface. We're going to handle MTUs, jumbo frames, and the mediums have to be point to point so that we can use a numbered interface. Now I'm going to enable OSPF. Going to enable multicast on the interface, so that should do it. I'm going to do this. I'm going to copy all of these and paste on define 2. Going to change the router ID, loopback 0 interface, and that will be the same. It's going to be the same. RP address will be the same. Will be the same. That's okay. So just going to save this, and I didn't enable those features. Okay, now let me paste all of this, and it starts with leaf 1. What do I have to change? So I need to enable the feature. I believe it's done already, and the router ID is going to be 11, loopback 0 is going to be 11, and I don't need loopback 1, and I don't need encast configuration, so that should do it. And I'm using one in interface number 1 and number 2. That should do it. So leaf 1, leaf 11. Okay. Okay, let me copy and change. So by using Notepad, it's faster to make changes and deploy the configuration. This is going to hang for a while. The loopback 0 is going to be 12. Everything else is the same. Let me copy. Done. So let me see. Show IP SPF neighbor. Okay, show IP route SPF. Okay, I see 112, 1 and 2. So leaf 12 should be online as well. So IP SPF interface brief. Okay, show IP pin neighbors is done. So IGP and OSPF, they are operational now. Leaf 3 or 13 is going to hold for a while. 1, 2, 3, 4. Okay. So right now let's just focus on leaf 1 and leaf 2. So everything is in place to start configuring VXLAN. So what we're going to need is the feature is going to be VN segment VLAN and feature NV overlay. And I'm going to create VLAN 10 and VN segment. That's going to be VXLAN ID. It's going to be 1, 2, 3, 10. It's done. Now NV interface is enabled, and update source from loopback interface, and it helps. Source interface loopback, yes. And source interface loopback, and the member VNI for 1, 2, 3, 10. It's going to be the multicast group 223, 224, 65, 74, 5. Okay, this is done. Now the interface where my host is connected, going to make it an access port and part of VLAN 10. And let's do its things. Now the same for leaf 2. So the feature is going to be VN segment, VLAN based, and feature NV overlay. Let me check here. So router 6 was already added to the MAC address of the switch. Now here we have to create the VLAN 10 and VXLAN ID. It's going to be 1, 2, 3, 10. NVE is going to source interface on loopback interface. Going to enable the interface, and it's going to be part of VNI 12310 multicast group 224 65 74 5. And let me see where R8 is connected. 1.4. So 1.4, going to make it an access port and part of VLAN 10. So if I look my MAC address table, I should know about. Okay, there we go. So R8 MAC address on VLAN 10. So right now, beliefs, they only know about the directly connected hosts. They don't know about remote hosts. So let me bring Wireshark so we can see these in action. So I'm going to look and minimize these. Port 11 and port 12 of leaf 1. And the same for port 1 and port 2 of leaf 2. Okay, so right now let's take a look at router 6 ARP table. So right now it's empty, meaning it doesn't know about R8 yet. So let's send some packets and see how this is going to play. It's going to be 10.8, and we can see the ARP. And let me see if I can stop this for a while. I believe it got the response already, so. And let's see, so this is ARP packets, and it's sourcing from R6. We can see that the request from R6 is a broadcast destination, and if we take a look at the packet, we can see that the source MAC address is R6, destination it's empty, and at layer 2 this is going to be sourced from R6, and this is a broadcast address that is going to be encapsulated inside VXLAN 12310, and it's going to be encapsulated inside the UDP packet and sent to port 4789. And because this is a broadcast packet, at the VTEP level, they're going to send this to the multicast address 224.65.74.5. And all VTEPs that are part of this group, they're going to receive, and one that has that host on this IP is going to reply, and that's what happens with VTEP 2. And we can see that the next one, we see that the packet, so actually here we see 10.8, this is the reply from leaf 2 saying that 10.8, that's its own MAC address. And when the ping starts working, we see that right now at the VTEP, they're using a unicast communication. This is directly from VTEP 11 or leaf 1 and leaf 2. And at ICMP level, as directly from 10.6 to 10.8. Okay. And if we look at the MAC address table, let's run the command again. So leaf 12 now knows about R6 MAC address as well via VTEP tunnel. And the same should be true for leaf 1 that knows R8 MAC address from the tunnel interface. So now let's deploy BGP EVPN and see how it's going to change the topology. So on spine 1, so we'll need to enable BGP and the feature overlay EVPN. Going to use 64.512 as ASN, and the neighbor will be 011. Remote AS 64.512. Update from the loopback interface, and address family, L2 VPN, EVPN, and we're going to, because of route target, it's an extended community, so we're going to send extended community, extended, and let's make this a router vector client. Let's first enable here and see if everything is okay. Spine 1. Okay, what is spine 2? Okay, now everything is okay, then I just have to replicate. Okay, so this means that I have to do the same 3 times for 12 and 13. Okay, paste this. Done. I'm going to do the same on spine 2, and this is done. Now leaf 1 or leaf 11. We're going to do the same. First, have to enable this feature. Leaf 2 as well, and let's bring leaf 13 to the picture. It's, see, where is it? So it's going to be similar to leaf 2, so we change here the IP. That's the same, it's the same. First I have to enable the features and then paste this. Okay, and let it roll. Now for leaf 1, so we want to enable BGP and peer with spine 1, and we are not a client, and 02, and that's it. And let's remove this. Additionally, at NVE, what we want, the host reach ability protocol will be BGP, and EVPN VNI, let's say 123.10. Layer 2, the route distinguisher will be auto, and the route target's going to be auto as well. So let's first check BGP configuration. Everything's okay. Okay, I just have to paste this and paste the same here. Okay, that's great. Now NV, done. Oh, it's missing. Okay, this part. Something is missing. Let me see. Show run feature. Ah, okay. VXLAN is not enabled, so VN segments and NV overlay. And NV overlay, EVPN, that should be okay. And now, wait, right? Oh, really? Features sensible. Okay. And now on leaf 13, this is going to be another tenant. It will be part of the VN segment that will be deployed on leaf 2. So it's going to be VLAN 20, and the VN segment will be 123.20, and that's it. NVE1, and let me see what I have configured already. Okay, so no shutdown, source, loop back, and member VNI is 123.20, and the multicast group is going to be 224 65 74 6. Now my host is on port 14 and won't be part of VLAN 20. Okay, and that's it. So you should be okay. Additionally, EVPN, we have to say that VNI 12320 layer 2, the route distinguishers should be auto, and route target for both import and export should be auto as well. So if we look at BGP L2 VPN EVPN summary, the adjacency is established, and I should be importing my MAC address, my host MAC address, into BGP. And I am. We can see R9 MAC address. Okay, so right now I'm not receiving or sending MAC address from others. So let's see leaf 2, what I have done so far. Okay, so I need VLAN 20. Have I configured yet? Okay, so VN segments 1, 2, 3, 20 done, and NVE1 and member, and no, it's okay, and member VNI going to be 1, 2, 3, 20, and multicast group 224 65 74 sticks. That's it. Show run inc NVE1, and I have 1, 2, 3, 10, 1, 2, 3, 20. That's okay. Now let me check EVPN. Okay, so EVPN configuration for VNI 1, 2, 3, 10 layer 2, route distinguisher should be auto, and the route target for both should be auto as well. As for VNI 1, 2, 3, 20 layer 2, just the same thing. Okay, so now I should already have information about R9. You see that R9 and R7, they didn't send any packet yet, but because of BGP, now the VTEPs, they are advertising this information to the route reflector, and the route reflector is reflecting those routes to all the other VTEPs that are part of the same group. And actually I should be able to show this here if I can. Should be in BGP update packet. Let's see if it's this one. Update packet, yes. So let's see, this is sourcing from 02, so that's the spine reflecting to leaf 2. So let's see, update message, path attributes, originator leaf 3. Okay, what do you have there? Plus the list, and I find information about the prefixes. It's here, layer 2 VPN, network layer reachability information, EVPN, and we can see the MAC address, and that's it. So that's the MAC address of R9 that is being advertised from leaf 3 to leaf 2. So now if I try to ping R9 from R7, let's put this button and auto scrolling. I wish. Let me drag this one as well. Okay, so let's check R7 our table. Right now it's empty. It doesn't know about R9 yet, and it's going to send a broadcast. So it's going to be 29, and shouldn't take longer to get a reply. So you can see, let's see, did it leave? Sourcing from 0 12. So this is performing the registration. Let's send once more. So it looks like something is missing. So lift 2 knows about 7, and am I? Is it 7 and 9? Yes. Let me see. Where is 7? Oh, that's the problem. 7, it's not on VLAN 20 yet. The switch port hosts and switch port access VLAN 20. Yeah, so now that should work. Show MAC address. And we can see now both are on VLAN 20 and R9 being received from lift 13. So now if we try again, that should work. And that works. And we can see the ICMP packet was sent to R9 and we got reply. So if we look our tables, so now R7 knows about R9 MAC address. So that's it, guys. VXLAN EVPN. So have some improvement at control plane thanks to BGP EVPN. I hope you guys enjoyed, and I'll see you on the next one.